Hi, I'm Jeffrey Diana, doing my course project in ECE 231. Then I uh, chose discrete time signals and systems to discuss in this project. Let me share you my screen. This is discrete time signal and system in ECE 231. I'm Jeffrey Diana, Bachelor of Science in Computer Engineering. This is my chosen topic regarding in this project. Topic to discuss. First, the discrete time signals, sequences. And number two is discrete time system. So for discrete time signals sequences, first we need to discuss about the taxonomy of signals. So signals, a function that conveys information. Here in the below diagram, we will see the amplitude and the time in this diagram. So for the time is continuous and discrete. For the analog signals is continuous and discrete time signals. For discrete, it is continuous time signals for the digital signals. So what is discrete time signals? So discrete time signals are represented by sequence of numbers. The nth number in the sequence is represented with xn. So oftentimes sequences are obtained by sampling of continuous time signals. In this case, xn is value of analog signals at xc times n t. So where t is the sampling period. Here in the diagram, we will see the discrete time signal that are represented by the xc times the nt. So for the representation by a sequence, discrete time system theory concerned with the processing signals that are represented by the sequences. X is equals to bracket x times the n, close bracket, which is, it is negative finite less than n less than to the infinite, positive infinity. The important sequences by, for example, the unit sample sequence, delta times the n, sometimes called a discrete times impulse or an impulse. So for our equation of delta times n is equals to 1 times 0, n is equals to 0, and n is not equals to 0. So xn delta n minus m is always equals to x times m delta n minus m. So discrete time signals sequences, important sequences. Number one is unit step sequence for u times the n. So for u times the n is equals to 1 times 0. N is less than, greater than or equals to 0, and n is less than to 0. In our diagram, this is the equation for these important sequences of unit step sequence un. Un is equals to the summation of infinity, m is equals to 0 times delta n minus m, or delta times n is equals to u times n minus u times n minus 1. So here our graph for the important sequences of unit steps sequence. For these examples, we have u times n. For the x coordinates, it's -8, -7 to -1. And for the positive side, it's 1, 2, 3 to 10, so on. For this is infinite. So for the next important sequences is the sinusoidal sequence. So for the sinusoidal sequence, xn is equals to a cos times n omega subscript o plus omega sine. For our diagram, we will see the sinusoidal sequence graph for x times n. And this is the diagram for the sinusoidal sequence. Next is the complex exponential sequence. So for the formula of complex exponential sequence, xn is equals to e. Superscript for the e is delta plus j omega o times n is equals to e omega n e j omega 0 n is equals to a n e jw or omega 0 n for the complex exponential sequence. So for the periodic sequences, a sequence xn is defined to be periodic with period n if, for the example here in our formula, xn is equals to x close and open parenthesis n plus the big N for all the n or the numbers. Example, consider xn is equals to e superscript j omega 0 n. So here are the sample formula to consider in the periodic sequences, which is a sequence is defined to be periodic with period n if. So this is the formula, xn is equals to e superscript j omega 0 n is equals to e j omega 0 times the small n plus big N is equals to e j omega 0 n, the big N, e superscript j omega 0 n is equals to x times n plus the big N. So for this formula, the next step will be the omega subscript 0, the big N is equals to 2k pi. And the next step is n, the big N is equals to 2k pi divided by omega 0. Then the final steps will be the 2 pi divided by omega subscript 0. This number must be a rational number. So for the operation of sequences, for the sum, x plus y is equals to curly bracket x times n plus y times n. For the product, x times y is equals to curly bracket x times n y times n. For the multiplication, it's a times x is equals to curly bracket ax times n. For the shift in operation of sequences, y times n is equals to x times n minus n subscript of 0. And for the reflection of operation and sequences, a times n is equals to x times negative n. The sequence representation using the delay unit, our formula will be x times n is equals to summation of infinite and negative infinity. K is equals to negative infinity times x times k and the delta n minus k. Here in the diagram shown, that the xn for the sequence representation using delay unit, the -3, and for positive A1, then 2, and the summation will be xn is equals to a subscript of -3 here in the diagram, which is delta times n plus 3 plus a subscript of 1 delta times the n minus 1 plus a subscript of 2 delta n minus 3 multiplied by delta n minus 3 plus a subscript of 7 delta multiplied by n minus 7. The energy of a sequence. What is energy of a sequence? Its energy of a sequence is defined by, for the formula in the diagram, is equals to E equals to N is equals to infinity, N is equals to negative infinity, multiplied by X times N squared. So let's talk about the discrete time systems. What is discrete time systems? So the signal processes systems are shown in this diagram. For the continuous time signal, the signal will go into analog system and the output is continuous time signal. So for the discrete time signal, the signal flows in the discrete time systems and the output will be discrete time signal. And for the digital signal, the signal will go as a digital system and the output will be as a digital system. So for the definition of discrete time system, a discrete time system is a device or algorithm that operates on a discrete time signal called the input or excitation according to some rule to produce another discrete time signal called the output or response. Here in the diagram, the input signal or the excitation x times n is going to t. T is for the time. Going to y times n is equals to t x times n. This is for the output signal of or the response signal. This expression denotes also the transformation t, also called operator or mapping or processing performed by the system on x times n to produce y times n. For discrete time system analysis, it is the process of determining the response y times n of the system described by an operator for the transformation t or for the mapping or its impulse response h times n to a given excitation x times n. This process could done also in Z minus or frequency domains. For the discrete time system design, it is the process of synthesizing the system parameters that satisfy the input output specification. So this process could done also in time Z minus or frequency domains. For the digital filter, it is a digital system that can be used to filter discrete time signal. Filtering is a process by which the frequency spectrum of the signal could be modified or manipulated according to some desired specification. For the classification of discrete time system, number 1, we will discuss the static, which is also called memoryless versus dynamic system memory, time varying versus time invariant system, linear versus non-linear system, causal versus non-causal system, stable versus unstable system. So for the static versus the dynamic system, a discrete time system is called static or memoryless if its output at any time, instant n, depends on the input sample at the same time, but not on the past or future samples of the input. So in other case, the system is said to be dynamic or to have memory if the output of a system at time n is completely determined by the input samples in the interval of small n minus the big N to n times n, the big N, is greater than or equals to 0. So the system is said to have memory of duration n. So if n is greater than or equals to 0, the system is static or memoryless. If the condition 0 is less than n, less than to the positive infinity, the system is said to have infinite memory. So if n is a infinite, the system is said to have infinite memory. So the static memoryless systems, for example, yn is equals to nx times n plus bx superscript 3 times n, the small n. The dynamic system with finite memory, y times n is equals to summation of the big N, k is equals to 0, h times k times x times n minus k. So for the dynamic system with infinite memory, y times n is equals to the summation of infinite k is equals to 0, h times k times n minus k. Next, time varying versus time invariant system definition. A discrete time system is called time invariant if it is input-output characteristics do not change with time. In the other case, the system is called time variable. Time invariant, or also called shift invariant systems, the definition is a time shift at the input causes corresponding time shift at output. So here in our formula, x times n, or x times n minus n subscript of 0 will go to time or time mapping. Going to y times n is equals to t, the big T, or time mapping, x times n. For the y times n minus n subscript of 0 is equals to t, the big T, or time mapping, x times n minus n subscript of 0. For the examples of time varying versus time invariant system, the static memoryless system, or the time invariant systems, for the formula y times n is equals to x times n plus b x over superscript 3 times n, or other formula y times n is equals to summation of n, the big N, k is equals to 0, h times k, x times n minus k. For the time variable systems, formula y times n is equals to nx times n plus bx superscript 3 times n minus 1, or in other formula, y times n is equals to the summation of the big N, k is equals to 0, h superscript the big N minus the small n, k x n, k times x times n minus k. For the example of time invariant systems, the accumulator system, the formula is y times n is equals to the summation of n over k is equals to negative infinity times x, negative infinity x times k. So for the shift the system by m, then the output y times n minus m is equals to the summation of n minus m, k is equals to negative infinity x subscript of 1 times k. So let the input x times n minus m is equals to, then the output y subscript of 1 times n is equals to the summation of n over k is equals to negative infinity x open parenthesis k minus m, close parenthesis. So let the big K is equals to the small k minus m. Then y1 times n is equals to the summation n minus m over k is equals to negative infinity x times k is equals to y, open parenthesis, n minus m, close parenthesis. Hence, the system is called time invariant system. For another example of time invariant system, the accumulator system, for the formula y times n is equals to nx times n. For the shift system by m, then the output y n minus m is equals to, open parenthesis, n minus m times x, open parenthesis, n minus m, close parenthesis. Then let the input x times n minus m, then the output is equals to y1 times n is equals to nx n minus m, not equal to yn minus m. So this is called, the system is time varying system. Now let's talk about linear versus non-linear systems. For the definition, a discrete time system is called linear if only if it satisfies the linear superposition principle. In other case, the system is called non-linear. In our diagram, x times n going to t for the mapping, going to y times n is equals to t, the time mapping x times n. So for further formula, t ax subscript of 1 times n plus the bx subscript of 2 times n is equals to a, then the t times x1 times n plus bt x subscript of 2 times the n. For the examples of our linear system, for the formula, y times n is equals to the summation of the big N, k is equals to 0, h times k times x, open parenthesis, n minus k, or other formula is y times n is equals to x n squared plus, not squared, x, open parenthesis, n for the power of 2 plus bx n minus k. For the formula of nonlinear systems, y times n is equals to nx times n plus bx power of 3, open parenthesis, n minus 1. In other formula, y times n is equals to summation of the big N, k is equals to 0, h times k multiply by x, open parenthesis, or multiply by n minus k, multiply by x, n minus k plus 1 for the non-linear systems. For the example of linear system, we will discuss about the accumulator system for the arbitrary input and for the arbitrary input, and then let the input and the output for the non-linear system. So the accumulator system for the formula is y times n is equals to x power of 2 times n. For the arbitrary input, x subscript of 1 multiplied by n, then the output will be y minus subscript of 1 times n is equals to x subscript of 2 and superscript subscript of 1 superscript of 2 times n. And for the arbitrary input of x subscript of 2 multiplied by n, then the output will be y subscript of 2 times n is equals to x superscript of 2 subscript of 2 multiplied by n. So let the input x times n is equals to ax subscript of 1 times n plus bx subscript of 2 multiplied by the small n. Then the output should be y times n is equals to ax subscript of n plus bx subscript of 2 n multiplied by power of 2. So y times n is equals to a squared x subscript of 1 superscript of 2 times n plus abx subscript of 1 times n x subscript of 2 times n plus b superscript of 2 or b power of 2 x subscript of 2 superscript of 2 times n, then y times n is equals not equals to a1 subscript of 1 times n plus by subscript of 2 times n. So for this formula, the system is non-linear system. Next topic is about the causal versus non-causal systems. For the definition, a system is said to be causal if the output of the system at any time. So for the example, time n, y times n depends only on a present and past inputs. For example, x times n or x times n minus 1 or x times n minus 2, so on and so forth. In mathematical terms, the output of a causal system satisfies an equation of the form. So for the formula, y times n is equals to the capital F, x times n or x times n minus 1 or x times n minus 2, so on and so forth, where f is some arbitrary function. If a system does not satisfy this definition, it is called non-causal. So for the examples of the causal system and non-causal system, for the formula of causal system, y times n is equals to summation of the big N, k is equals to 0, h times k multiplied by x times n minus k, or other formula, y times n is equals to x power of 2 times n plus bx times or multiply by n minus k. For the non-causal system, the formula is y times n is equals to nx n plus 1 plus bx power of 3 multiplied by n minus 1. Other formula, y times n is equals to summation of 10, k is equals to negative 10. So positive side is 10, negative side is negative 10, multiplied by h times k x, or multiplied by x times n minus k. So for example, let's check the discrete time system for causality if its response is of the form. So for our given, y times n is equals to r, x times n is equals to 3x n minus 2 plus 3x n plus 2. So for b, y times n is equals to rx times n is equals to 3x n minus 1 minus 3x n minus 2. So let's solve this. Let's solve these examples. So for the solution, so for our solution in this problem, let's share it or solve it in the white screen or whiteboard. So for n is equals to k, so r x 1 times n is equals to k, then 3x 1 times k minus 2 plus 3x 1 times k plus 2. So for x2, so r x2 times n, so close bracket, n is equals to k equals to 3x2 multiply by k minus 2, same as the formula in x1, k minus 2 plus 3x2 k plus 2. And since we assume that x1 times n is not equal, let's assume that x1 times n is not equals to x2 times n. They are not equal. So for n, the small n is greater than k. So it follows that x plus 1 or x1 k plus 2 close parenthesis is not equals to x2 k plus 2 open parenthesis k plus 2 and thus 3x 3x1 is k times k plus 2 k plus 2 is not equals to 3x2 k multiply by k plus 2. So therefore our r bracket x1 times n, let's close the bracket, is equals to r x2 times n. For n is equals to k small n and the small k. This formula is called, the system is called non-causal. For this case, let's solve another formula. So r the bracket x1 times n, close bracket, n is equals to k. So n is equals to k equals to 3x1 k minus 1 plus 3x1 k minus 2. So for rx x2 or for r x2 times n, close the bracket, n is equals to k equals to 3x2. Let's change 1 by 2, k minus 1. So k minus 1, then plus 3x2, k minus 2. If n is less than or equals to k, then x1, k minus 1 is equals to x2, k minus 1, and x1 is multiplied by x minus 2 equals to x2, k minus 2. So for n is less than or equals to k, or rx, or r bracket, open bracket, k minus 1, k1 multiplied by n is equals to rx2 times n. So for n again is less than or equals to k, then the system is called the causal system. This is causal system. This is causal. So now let's discuss another topic, the stable versus unstable of systems. For the definition, an arbitrary relaxed system is said to be bounded input, bounded output, or the BIBO. Stable if and only if every bounded input produces the bounded output. It means that there exists some finite numbers, say mx and my, such that the x times n is less than or equals to mx, or m subscript of x less than to the infinity, the positive infinity, going to, if and only if y times n is less than or equals to m subscript of y is less than to the positive infinity. So for all n, if for some bounded input sequence x times n, the output y times n is unbounded infinite, the system is classified as unstable. So this is unstable system. Let's test for the testing for stability or instability of a system. So for y times n is equals to, open parenthesis, k or x times n, the power of 2, is stable if x times n less than or equals to b subscript of x is less than to the positive infinity. So for all n, then y times n is less than or equals to b subscript of y equals to b power of 2 subscript of x less than the positive infinity for all n. So let's test for the stability or the instability. For the accumulator system, y times n is equals to the summation of n, k is equals to negative infinity x times k. So for x times n is equals to u times n is equals to 0 over 1. For n is less than 0 and n is greater than or equal to 0, this is bounded. So another formula, y times n is equals to n, summation of x is equals to negative infinity, x times k is equals to n, summation of x is equals to negative infinity, x times k is equals to 0, n plus 1, for n is less than 0, and n is greater than or equals to 0, this is not bounded. So this accumulator system is not stable. For the characterization of discrete time system, any discrete time can be characterized by one of the following representation. Number 1, difference equation, impulse response. Number 2, number 3 is transfer function. Number 4 is frequency response. So let's talk about the difference equation. So continuous time systems are characterized in terms of differential equation. Discrete time systems, on the other hand, are characterized in terms of difference equation. A LTI system can be described by a linear constant coefficient difference equation of the form. So we have two example of the summation or the formula for this LTI system, which is the big M, the summation is equals to I is equals to 0, B subscript of I, Y times N minus I equals to the summation of the big N, I is equals to 0, A subscript of I, X times N minus I, or Y times N is equals to summation of big N, I is equals to 0, A subscript of I, X times N minus 1 minus the summation of the big M, I is equals to 1, B subscript of I, Y times 9 minus I. So this equation describes a recursive approach for computing the current output, Y times I, given the input values, X times N, and previously computed output values, Y times N minus 1 or N minus I. B subscript of 0 is equals to 1. The big M and N are called the order of the system. AI and BI are constant coefficient. Two types of discrete time systems can be identified, which is the non-recursive and the recursive. So for the definition of the recursive versus non-recursive systems, continuation, a system whose output Y times N, N at time N depends on any number of the past outputs values. For the example, Y times N minus 1 or Yn minus 2, so on and so forth, is called a recursive system. Then the output of a causal recursive system can be expressed in general as, for the summation, for the formula, Y times N is equals to the big F, open the bracket, Y times N minus 1 times N minus 2, so on and so forth, Yn, the small n minus the big N, X times N or X times N minus 1, so on and so forth, and X, open parenthesis, N minus M, or X times the N minus M, the small n, and small m. So where F for the mapping is some arbitrary function. So in contrast, if Y times N at time N depends only on the present and past inputs, such as a system is called non-recursive system. For the example of the non-recursive system and the recursive system, non-recursive system formula, which Y times N is equals to the summation of the big N, K is equals to 0, H times K multiplied by x times n minus k. So for the recursive system, y times n is equals to the big N, summation of x, or summation of k is equals to 0, b times k multiplied by x times n minus k minus the big N, summation of k is equals to 1, a multiplied by k minus n minus k. To solve the difference equation, compute impulse response of the linear time or LTICS that described by the following differential equation. So for the LTICS in differential equation, y multiplied by n minus a y multiplied by n minus 1 is equals to x times n. So for the solution, since the system is causal system, then yn is equals to 0 for n is less than 2, 0. Then the system input is x times n is equals to delta times n. Then the output can be calculated as follows. Y times n is equals to ay n minus 1 plus delta times n. So if at n is equals to 0, y times 0. So equals to a1 times negative 1 plus delta 0 is equals to 1. So for the answer in n equals to 0 is a, this is a subscript or the power of 0. In n minus n is equals to 1, ay multiplied by 0 plus delta 1 or delta times 1 is equals to a. This is equals to a power of 1. At n is equals to 2, a times y multiplied by, or ay times 1 plus delta times 2 is equals to a power of 2. At n is equals to 3, y times 3 is equals to ay times 2 plus delta 3 or delta times 3 is equals to a power of 3. So here, the general form of the output will be y times n is equals to a power of n for n is greater than 0. So here in this diagram, we will discuss the discrete time system network. So there is element, the symbols, and the equation. So for example, the unit delay, the other, the multiplier, and then the symbol for the unit delay and the equation for the unit delay. For the other, this is the symbol of the other, and this is the equation for the other. So the equation for the other, y times n, the big T, or multiplied by the big T or the mapper, is equals to the summation of the big K, I is equals to 1, x subscript of I multiplied by n times T. And last, the multiplier, this is the symbol for the multiplier, and this is the equation for the multiplier, y times n multiplied by the T mapping is equals to m times x multiplied by n and T. So for the basic elements of the discrete time systems are the other, the multiplier, and the unit delay, where f is some arbitrary function. Ideally, the other produces the sum of its input, and the multiplier multiplies its input by a constant instantaneously. The unit delay, on the other hand, is a memory element that can store just one number at instant n multiplied by t in response to a synchronizing clock pulse. It delivers its content to the output, and the n updates its content with the present input. So the device freezes in this state until the next clock pulse. In effect, on the clock pulse, the unit delay delivers its previous input to the output. So for example, for the discrete time system shown in the figure, if the system is initially relaxed, That is y times n is equals to 0 for n is less than 0 and p is a real constant to the following. So first, we need to derive the difference equation. Next, derive the impulse response, h times n. Then check the system stability. Then lastly, find the unit step response of the system. This will show here below in our diagram. So for the solution of the impulse response, h times n of the system, this is illustrated in the figure below. So for the stable system, h times n. And for the unstable system, this is p, represented by p greater than 1. And this is also the unstable system if h times n, p is equals to 1. So here is the check to check the stability for p less than 1 and n, the p times n plus 1, 0. And in this case, the system is the stable one. So shown here in the system stability, the formula n summation of k is equals to 0. H times k is equals to n summation of x is equals to 0. P, the power of k, is equals to 1 minus p, power of n plus 1 over 1 minus p for the stability, or to check the stability of the system. So for the infinity summation of k is equals to 0, h times k is equals to summation of infinity, k is equals to 0, p the power of k is equals to 1 over 1 minus p. This is less than the infinity, the positive infinity. With x times n is equals to u times n, we get y times n is equals to x times n plus py n minus 1. So for sample, y is equals to, or y0 or y times 0 is equals to y, or 1 plus py minus 1. This is equals to 1. For y1, or for y times 1 is equals to 1 plus py multiplied by 0. For the answer is 1 plus p. For y2 is equals to 1 plus py times 1 is equals to 1 plus p power of 2. So for the final summation, y times n is equals to u times n. The summation of n, k is equals to 0, p, the power of k, is equals to u times n, 1 minus p, n plus to the power of n plus 1 over 1 minus p. For the solution of unit step response for the three values of p is illustrated in the below figure. Evidently, the response converges if p is less than 1 and diverges if p is greater than or equals to 1. So here in our first diagram, the diagram A, p is greater or less than 1. So y is for the summation of y times n times t, p is less than 1. So next diagram, p is greater than 1. So y times nt, p is greater than 1. And for the last diagram, c is equals to, or c, for the c, p is equals to 1. The y times n times t, p is equals to 1. So this is my last and final equation for the solution in solving the LTICS, or linear time invariant systems. This is the example to compute impulse response of LTICS that describe the following. Let me share the whiteboard. Okay. So for the given equation, y times n, a times y, so n minus 1 is equals to x times n. So since the system is a causal system, then yn or y times n is equals to ay n minus 1 plus delta times n. So let n is equals to 0. For n is equals to 0, our y is equals to 0. Then it equals to y negative 1 o times negative 1 plus delta 0 is equals to 1, or a superscript 0. This is for n is equals to 0. If at n is equals to 1, so our formula will be ay times 0 plus delta 1 or delta times 1 is equals to a. So the answer is a, or a superscript of 1. At n is equals to 2, for n is equals to 2, so let a times y times 1 plus delta times 2 equals to a superscript of 2 for the n is equals to 2. And lastly, for n is equals to 3, the solution will be y times 3 is equals to ay or a times y multiplied by 2, then add with delta times 3, and the answer will be a superscript of 3. Then the general form of this output will be xn or yn, sorry, yn is equals to a power of n for n is greater than 0. So the calculation is a causal system. Thank you and good luck.